Hi folks, so in this video we're going to take a look at the concept of density. Now density is the idea that occasionally if you have an object, say in water, that smaller objects, lighter objects, sink, whilst larger, heavier objects appear to float. And the idea here is, why does something light sink while something heavy can float? And floating and sinking isn't governed by how heavy an object is, though it appears to be. It is in fact governed by how well concentrated that mass is. So if you have an object that is like a pebble, for example, that is light but occupies very little space, then it will sink to the bottom of water or a gas or whatever. Whereas if you have an object that's very, very heavy, say for example a large boat, but because of the fact that it occupies a large amount of space, that mass is spread out massively, and therefore the object can float. And this concentration or spreading out of mass in a given amount of volume is called the density, and is given by the equation density equals mass divided by volume. So if the mass goes up, the density gets larger. If the volume goes up, however, the density gets smaller. So we've got a few things here to run through. First of all, mass is measured in different units. For very small masses, we'll measure mass in grams. For larger masses, we'll measure it in kilograms. We rarely use tons or pounds or anything along those lines. These are our two units here. Volume, on the other hand, has a few different ones. There are the standard units of volume that for small objects you would tend to use centimeters cubed, or for extremely small objects, maybe millimeters cubed. And then for much larger objects, you'd have meters cubed. But if you happen to have a rogue chemist or a chemistry teacher, or you're actually doing an experiment in a lab, you'll tend to get your volumes in milliliters. And this is an issue because we don't want density coded in milliliters. We don't want our volumes in milliliters. But it is handy to know that 1 milliliter is equal to a centimeter cubed. They are, in fact, the same measurement. So we don't use milliliters when we're doing our calculations. We simply change ml to cm cubed. And that's going to become important later on. This is a pretty standard exam trap as well that's set, that checking to see if people will use milliliters instead of centimeters cubed. Okay, so let's pop on a little bit and see if we can make this work. Let's imagine that we have some particles in a container, and these particles have a total mass of 50 grams, and they are occupying a volume of 70 milliliters. So what we'll want to do is we'll want to calculate the density of this. So we'll use the equation density equals mass divided by volume. That's our equation. Then we can say that the density is equal to the mass, and in this case the mass is 50. It's 50 grams, we'll deal with that later, divided by the volume, which is 70 milliliters. That's going to be a problem, but we'll deal with it again later. We'll just do with the numbers now. So density, if I can spell it correctly, density equals 50 divided by 70. So we go and grab our calculator, we put 50 divided by 70 into it, and we'll do 0.714 to 3 decimal places for our answer. Now, our unit, what do we actually measure this in? Well, our mass was measured in grams, and our volume was measured in milliliters. So we should have it as grams divided by milliliters. But remember, we don't use milliliters in our conversion here. What we use is centimeters cubed. So we're going to change that ml out and turn it into cm cubed. So notice that we have 50 grams divided by 70 milliliters becomes grams divided by centimeters cubed here. Okay, now in future calculations we'll want to change this density equals mass divided by volume into letter format. So we'll use D equals M over V. It's a little bit faster, but for this first one, then we just took care of that. In this one, what we've got is we have 50 milliliters worth of particles, and we've got 100 grams of particles. So again, we'll go for our equation, density equals mass divided by volume. I'm using a capital V for volume and a small m for mass. So D equals the mass is 100 grams divided by the volume, which was 50 milliliters. This is a slightly easier calculation, do it in your head, but if you're in an exam, pop it into your calculator just in case. There's no point taking the risk in exam situations your brain can sometimes go into shutdown and very simple calculations become very difficult. But the answer here is 100 divided by 50, which is 2. The unit for the mass is grams. The unit for the volume is milliliters, but we have a little bit of a panic attack when we write that in because we're not allowed to, so we change that from milliliters into centimeters cubed. And it's as simple as that. Okay. Now, in more complicated questions, rather than just being given the volume and the mass straight up, you might get the mass in kilograms. You might get the shape like a cube, and you're told to find the volume first. But we'll have a look at those in our questions section, which is coming up now. The core concept is density equals mass divided by volume, and it's just play with that equation. Alright, so let's do some sample questions. So in this question we have a material with a mass of 200 grams and a volume of 40 centimeters cubed. What is the density? And we're being awarded 3 marks for this. So we're looking for the density, so our equation is density equals mass divided by volume. So we're using that. We're finding the density, so we don't know that. The mass is 200 grams divided by the volume, which is 40 centimeters cubed. So my density equals 200 divided by 40. Again, we should use our calculator for this. That comes out to be 5. Unit for mass is grams. Unit for volume is centimeters cubed. We're okay with grams per centimeter cubed as our answer. So that's us done. And the 3 marks available here are for each line here. So 1 mark for the formula, 1 mark for the working out, and 1 mark for the answer. Now, examiners usually will give you the unit they want here, so this doesn't get a mark. If that was separate, you'd maybe get a 4th mark for that. Okay, but for now, we've got 1, 2, 3 marks, and we're moving on to our next question. Okay, so question 2, a little bit of a different setup here. In this one, a cube has a mass of 50 kilograms and a side length of 2 meters. And our first part here is what is the volume of the cube, and then our second part is what is the density of the cube. So let's draw a little picture of what we're dealing with here. So I'm going to try and draw a diagram of a cube, which is generally not going to go very well because I'm not the world's best artist, as you might have noticed from the splash screen coming in at the start of this video. But that's sort of a cube. Yeah, it's good enough. It's good enough. Right, so let's go. So what have we got? We've got side length 2 meters. So that means that this side's 2 meters. And because it's a cube, all the sides have the same length. No, it doesn't look like that. It's 2 meters, 2 meters, and 2 meters. And then we have a total mass of 50 kilograms, which we'll just write in the middle here, just to remind ourselves. So we want to find the volume of this cube. So part 1, the volume. Well, what is the volume of a cube? The volume of a cube is equal to the length of the cube multiplied by the width or breadth of the cube multiplied by its height. So that would give me that the volume is equal to 2 multiplied by 2 multiplied by 2. And that gives me a volume equal to 2 times 2 is 4, times 2 is 8, and it's meters times meters times meters, which is meters cubed. So our volume is 8 meters cubed. And we're going to get given just 1 mark for that because you should have been able to do the volume of a cube since you were essentially in primary school, so you don't get anything extra for that. Part 2 here. Now, we want to find the density of the cube. So again, density equals mass divided by volume is our equation. And we want that the density is equal to its mass, which was 50 kilograms, divided by its volume, which was 8 meters cubed. So that gives me my density equals, once again, grabbing our calculator, we do 50 divided by 8, which gives me 6.25. Our unit for mass is kilograms divided by my unit for the volume, which was meters cubed. That's absolutely fine, and therefore we've got our answer. And we've got 3 marks for that part, which gives me, we're going to get 1 mark here, we'll get 1 mark here, and we'll get 1 mark here, giving me a total of 3. Now, error carried forward here. If you somehow had a brain fade and couldn't get the volume of this cube, you did 2 by 2 maybe and got 4, you get 0 marks obviously for this bit. But if you had a mistake here for the volume and you used it in here, you could still get 3 marks total for this because you have to use your previous answer to get this answer. And it wouldn't be fair to penalise you twice. This is called an error carried forward and is marked in exams as ECF, error carried forward. Now, error carried forward questions tend to be written with little Roman numeral notations beside them. But instead of this being 2A and 2B, it's 2I and 2II. And when you see that, what that means is the answer to a previous part can be used in the next part and may need to be used in the next part. So if you will get error carried forward in through here. Okay? And then finally, on to question 3. In this question, we have a sphere of density 50 grams per centimeter cubed, which has a mass of 3.2 kilograms. What is the volume of the sphere? Now, I've been given 4 marks for this, so I'm expecting something a little bit tricky. Okay, so let's draw ourselves a sphere. Right, so that's a circle. Let's make it sphere-y by giving it a little bit of gradient fill. There we go. That sort of looks sphere-y. And we've been told that it's got a mass of 3.2 kilograms. So that's popping 3.2 kg in here. And we've been told that its density is equal to 50 grams per centimeter cubed. Now, I've spotted the trick here. I hope you have too. That we have a density that's measured in grams per centimeter cubed. There's a G here. But we've been given a mass in kilograms, which means that we can't drop these two things into an equation together. We're going to have to get our mass into grams first. So 3.2 kilograms is equal to how many grams? Well, I know that there's 1,000 grams in a kilogram, so 3.2 kilograms is going to be 3,200 grams. And that's where my extra mark is for here. I get 1 mark for just recognizing that. After that, then, it's a straightforward density equals mass divided by volume setup for my equation. But on the next line, we realize that the game's not going to be as simple as it has been, because we've been given our density as 50, our mass is 3,200, and that's going to be divided by V. And I don't like divided by V, and I don't think anybody does. We want rid of that. We want that off the bottom line of the fraction, so we're going to multiply both sides by V. So times V there and times V there. And that gives me that 50V equals 3,200. Now again, I don't want 50V, I just want the value of V. So I'm going to divide by 50 on that side, and I'm going to divide by 50 on that side. I must divide both sides of the equation by the same thing, or multiply both sides of the equation by the same thing. Otherwise, what I'm saying is no longer mathematically true. And that then leaves me with V equals 64 as my numerical answer. Now I need to work out what the unit is here, like 64 what? Now, I know that my density was in grams per centimeter cubed, which means that my mass should be in grams and my volume then should be in centimeters cubed. Okay, so this means that my volume for my sphere is 64 centimeters cubed. Now, if you look in the description below this video, you will find a little homework sheet to have a crack at. Have a go at that, see how you get on. And one thing, last thing, most important thing, don't ever, ever, ever forget that physics rocks. It's true.